In today's lesson, introductory applications of magnetic separation, but the application we want to look at is separating metallic objects and grain. So what we are going to start with, tishatanga purpose. What is the purpose of learning about this? And what purpose does magnetic separation serve? Kana tichitarisa grain processing. So grain processing, we are going to learn about it from two fronts. Tichatanga tatarisa grain processing kumba, that is home-based. Then chazotarisa grain processing on a commercial level. Saka typically trikutarisa mbuya sekuru vari kumusha vari kugadzira chibage chavo chekuti vazonogaisa vadye sadza against an engineer or an agronomist ari kuGMB vari kuprocessa grain kuti vaise mudura renyika. Saka our purpose, tiri kuti magnetic separation is used to remove metallic objects, and we are going to outline a short list of it. Saka it's called magnetic separation, is used to separate kana kuti to remove, kuti tisava redundant, metallic objects such as what? Such as iron nails, anditika zvipikiri, wires, talk of screws, or even iron fillings, cannot filings from grain. And per grain, even though in Zimbabwe the grain we usually refer to is maize, but per grain trikutaura pamusoro pe maize, wheat, rice, etc. etc. So magnetic separation, we use it to separate. Typically magnetic separation inoshandiswa kana chida kuseparata magnetic material from non-magnetic material. So let us write it down. So kana chitaura pamusoro pe magnetic separation, tinoishandisa typically kuseparata magnetic material and non-magnetic material. Saka for magnetic material we usually refer to metallic objects. Kana kuti zvinhu zviri ferrous. And it kuti ferrous zvinobva pakuti Fe. Fe ndiyo the chemical symbol of iron kana tiri pa periodic table yatichatanga kudzidza pamusoro payo in a short while. So zvinhu zviri metallic, zvinhu zviri ferrous, ndizvo kazhinji zvinhu zviri magnetic. Magnets are attracted to metals. Saka patati metallic apa, you can put it simply as metals. Then zvinhu zviri non-magnetic zvinenge zviri non-ferrous, zvinenge zviri non-metallic, like this. So this is what we are dealing with kana chitaura magnetic separation. Changoitika panapa ndechekuti magnetic material yatiri kuseparata from grain, these are iron nails, wires, screws, iron fillings, etc. That is the purpose of what we are learning today. So tadzidza kuti magnetic separators are used to separate grain and metallic objects like iron fillings. Then tikatarisa these metallic objects, and maybe this is a very important note to put down. Maybe let me put it like this. Saka metallic impurities, because they are impurities, and impurity chinhu chiri chiri mumixture chatisiri kuda chacho. So metallic impurities decrease the quality of grain. Andika? I want you to imagine a scandal. Munhu odya palenda yatenga maokei. O palenda yaya inenge ine chipikiri mairi. Andika? Ozoenda kuchipatara voona kuti mudumbu make mune chipikiri. So prove you are without any reasonable doubt kuti chipikiri chabva mupalenda yakadya. Imagine that scandal. Vanochiti palenda inenge ine zvinhu chichichi, you understand? Saka the quality of grain is reduced by metallic impurities. And by metallic impurities, tukureva metallic objects which are then removed by use of magnetism. So these metallic objects decrease the quality of grain. Chimwe chinoita metallic objects aya ndechekuti they decrease the quality of grain, and what do they also do? Damage the equipment used in grain processing. And can potentially harm end users, and by end user to refer to consumers. Saka this is the purpose of doing this. Why do we do this? Why is it mukaenda pachigayo chega muchawana paine magnet pamuromo paya panopinda nechibage kuti chigaiwe huve hupfu? Metallic impurities, they decrease the quality of grain, can potentially harm the equipment. Chigayo chacho chiri kushandiswa kugaya, that is in grain processing, that grinding mill can be destroyed, and it can also potentially harm end users. Okay, so we have learned about the purpose. Tatanga taona kuti chimbori chi magnetic separation, ndokuzoona kuti nemhaka yei tichiita. What we want to look at now, takuda kutarisa principle. Zvinomboitwa sei? That is what principle is. Zvinomboitwa sei? So when it comes to principle, the first thing we have to talk about is metallic objects. Metallic objects like iron and steel are magnetic. Ndochatofanga kutanga kuziva. This is the principle iri kushanda. Remember takati there should be a physical property inofanirwa coexist between the components making up a mixture, so that we are able to separate one component from the other. Saka principle we are discussing the like pa principle panapa tangati kuona kuti physical characteristics for magnetic separation. We could have cited it down like this: physical characteristics for magnetic separations. Metallic objects which are making part of the mixture should be magnetic. Then secondly, tirikuti grain yacho is non-magnetic, and non-ferrous, non-magnetic. Okay, saka our mixture should be made up of what? Metallic objects plus grain. We should always remember this. And tukutaura tichiti chinonyatsokuitika ndechekuti, I'm going to explain this diagrammatically, but let us write a point. When a magnetic field is applied, metallic objects are attracted. So metallic objects are attracted. And while grain is unaffected. I want to explain this point. Okay. So to explain this point, let us say we have a mixture. In this mixture, it's mixture of, let us say, maize grain. But mukati me maize grain muneti tuma iron fillings utu turi tuviri. Saka isusu taudzwa kuti ndozviripo, we bring a magnet closer. And this is the north pole, the south pole. And we know kuti for a magnet, kana tiri kunze kwe magnet, it's always from north to south. Saka field inenge yakadai so. Like this. Like this. Okay. And saka patino swededza this magnet field chinopindawo panapa apa. Murikuzona. Ichabva yaattracta. The moment tuma iron fillings patinenge turi mukati me magnetic field. Takati magnetic field chi. Takati the area around a magnet where the magnetic force is the most concentrated. That's a magnetic field. And we discussed a lot about it. Tichiti how you can conduct a simple experiment to know the magnetic field of a magnet, etc. And what I have to add there is, it might be difficult kwa ma iron fillings because tusimbi twakakuiwa munotowana kupi. But kuri kuti matowana and you have your magnet, you can easily conduct this experiment. You can watch our first lesson on magnetism, cannot magnetic separation, because magnetism is topic ya physics asataita. Ku chemistry tunongoita magnetic separation. So the moment my iron fillings panning ari mukati me magnetic field, they are attracted towards the magnet. Ndo zviri kungoitika panapa. Attracted towards the magnet, like that. So I bet it's easy to understand kuti ndo zvinenge zvichiitika. Okay. Saka, we want to get into the method and process, but we have to first acknowledge that magnetic separation can be home-based or done on a larger scale. So let us look at the method and process. This is the subtopic we want to learn about, method, process. This is what we want to learn about. Saka, before we get into it, we should acknowledge kuti magnetic separation can be done on a small scale. And panaba, an example would be kumba, home-based, or larger scale. And it panaba techitishi commercially, cannot commercial use. An example would be grain marketing board, GMB. Saka zvese zvachadiscussa panapa tinenge tichitarisa maangles aya. Saka pachati small scale, fungai about kumba, fungai chigayo chenyu chiri mu areas and stuff. Pachati larger scale, fungai about GMB or those large grain companies. All right. So when it comes to the method, and step 1, Sakapa, let us put them in steps so that we can understand better. Step 1, grain is poured onto a moving conveyor belt or spread on a flat surface. Sakapa, step 1, kana iri small scale, kumba kweduku, pachigayo, and grain is spread on a flat surface. handitika. And flat surface can refer to ndichazokuratidza ichigayo panopinda nechibage paipai, because I think to be more practical, magnetic separation between grain and metallic objects inowanzokuitwa kuchigayo. Kashoma kuti one munhu achifamba aine magnet pachibage chanenge agadzira kuti aende nacho kuchigayo. So this is usually done kuchigayo. Then kana iri a large scale, we don't have big enough a flat surface, saka for a large scale tiri kuti grain is poured onto a moving conveyor belt. Sa conveyor belt chairo chibage chinodururwa chotanga kumuvha kudai so. Alright. Saka on a large scale, grain is poured onto a moving conveyor belt, so it has to be moving. The strength of magnets is different between different magnets. Saka the strength of a magnet depends on which scale we are using. If it is small scale, we use relatively weaker magnets. If it is large scale, we use relatively larger magnets. That is what is done. So this takes us to step 2. So for step 2, we are going to learn about electromagnetism. Nezuro I just hinted on it, but I told about John Clerk Maxwell and Michael Faraday, the advances in electricity and magnetism being married together in a field of physics called electromagnetism. I know kuti tichaita simple electromagnetism, but tinenge tichiita, I think it's called the right hand gesture kanenge kaishandiswa naMichael Faraday. But for now manje, we should know that for step 2, a magnet is tinogona kuti brought closer to the mixture, like this. A magnet is brought closer to the mixture. So we have a mixture of grain and metallic objects. We bring a magnet closer. But tofanga kuziva kuti the strength of the magnet depends on the scale. The strength of the magnet depends on the scale. And pakuti scale tiri kutaura kuti is it small scale, chigayo chemuraini? Is it large scale? Is it commercialized? So the strength of the magnet depends on the scale, but generally speaking, it should be a strong magnet. So a strong magnet or an electromagnet is placed above or beside the grain floor. And it saka brought closer, it's trungoreva kuti it's placed above or beside. So we can add panaba brought closer trikuti placed above or besides, like this. Okay, then we go to step number 3, and for step 3 we are just saying metallic objects are attracted to the magnet. And it metallic objects are attracted to the magnet. And it then when metallic objects are attracted to the magnet, then for our step number 4, then we clean grain, we collect clean grain. And it after metallic objects are removed. objects are removed. So in layman terms rungotaura apa ndezvekuti locally kana tiri kuchigayo we are going to pass chibage through a magnet so that kana muchibage umu muine tusimbi turimo tutaattractwa this magnet. Okay, but kana tichitaura commercial use, be it GMB grain marketing board or other large grain or seed companies, we are going to use industrial magnets. So what is basically happened panapa is this. Saka we have this magnet yedu inenge iri samwe panapa. Let me use a darker color kuti muone pandokureva apa. Kana makamboenda kuchikayo, you know what I mean. Ndopaniswa magnet ipapa. Then chibage pachinoiswa panapa anditi chichapfuura nepamagnet kana mune zvisimbi zvichiattractwa kumagnet, then eventually chichazouya kunokwava upfu. But kana tiri GMB and other large companies, they do not use small magnets like a magnet kanokwana. They use what are called industrial magnets, and in most cases they are electromagnets. We are going to discuss that in our physics. Saka that's an example of an industrial magnet, very strong, very big. And saka strength inosiyana nekuti muruda kushandisa magnet yacho for grain processing kupi. You get it? Okay, saka tadai so much tinenge tatobata patanga chifanirwa kubata. We know that a magnet is drawn closer to a mixture of grain and metallic objects. The metallic objects are attracted by the magnet once they are inside the magnetic field. Then a magnetic field again is just an area around a magnet where magnetic force is the most experienced or concentrated. Saka, let us now look at uses and importance. We are going to look at advantages. We are later going to look at also disadvantages kana kuti limitations. Tikadaro tinenge tapedza. Okay, so looking at uses kana kuti importance, we can also discuss these as advantages. Andidika like this. Okay, so the first thing is it prevents injury to consumers. Ukadya chisimbi chiri muupfu chinogona kutokukwadza, so it prevents injury to consumers. Not only to consumers, but it also prevents damage to milling machines, and it prevents damage to milling machines. Then it improves quality and safety of food. Improves quality and safety of foods. Safety of grain kana kungoti tinoti foods. Then it's commonly used in grain silos, milling industries, food processing plants. That's where it's commonly used. Then tikawedzera mamwe advantages anenge akadangofanana nemadvantage atakaita in our yesterday lesson, but ataura advantages and disadvantages of magnetic separation, how fast it is and how efficient it is. No chemical contamination of grain. Remember, it doesn't alter the chemical structure of grain, so no chemical contamination of grain. Tinowedzera futi tichiti it's simple to operate. Very simple indeed, insipid, and suitable for large scale processing. Suitable for large scale processing, like this. So this is it. Let us go to disadvantages, which can also be called limitations. Saka limitations, disadvantages. Apa tinongeta setiri kudzokorodza what we did in our yesterday lesson. Okay, so it only removes metallic objects, only removes metallic kana kuti magnetic impurities. Saka kana muine zvimatombo-tombo hazviaffectwi. That's a limitation, that's a disadvantage to the process. Secondly, non-magnetic metals, example aluminum, copper, are not removed. Saka we can have a metal which is non-magnetic. Muchazoona pacheta periodic table. So non-magnetic metals, example aluminum, copper, are not removed. They are left. And then it requires strong magnets. And for small metal pieces, saka proportionality, very small metal pieces ungochitoda a strong magnet. You always have to use a strong magnet. Relative strength ndio inosiyana nekuti which scale are you dealing with. Is it home based, small scale, is it large scale, etc. So this is all we had to learn here. If you want to contact us for extra lessons or just to liaise with us, WhatsApp us on 071 521 3310. Done, and thank you.